Hey folks, Dankman here. So watching this, it should be Thursday, May 14. Okay? And we're going to continue this thing factoring quadratics. And yesterday there was a bunch of stuff to go through to introduce this idea of how to factor this kind of expression. And in fact, I should go back even further in my review, at least briefly, and do an example like this, x squared plus 5x. So how did we factor x squared plus 5x? Well, looking at this x squared and 5x, I can see that there is a way to undistribute an x inside of both terms. And this is the process that we started with, where we start with a sum and we turn it into a multiplication problem, a product, and we identify in that product two different pieces. Each piece is called a factor. So there's a factor of x times this group, x plus 5. And so since there are two factors multiplying together, this is a product. So we're turning this into a product. And this one is a process where I can see that I could undistribute an x from both terms. Here, though, I can't undistribute anything from all three terms. I could try, and students love to try this, to undistribute an x from the start. Okay, and that's actually going to become really relevant next week. But right now, this has not completely factored the whole thing. It's just factored the first two pieces and left the 15 off there to die. And that's not really what we're looking for. We're looking for a strategy to factor this entire expression and turn it into a product, right? So we want to go, right now it's a sum, all the way into the entire thing can be rewritten as a product. And this is our review, so if you want to watch the entire video yesterday and the three examples, you can, but the basic story is that I know the shape of my product is going to look like two different pieces, x plus or minus something as a group, times x plus or minus something. And I'm going to look at this coefficient 8, and I recognize that that's going to be something important, and I'm going to basically want to find two numbers that add to 8 and multiply to 15. Okay, and the reasons again for this and all of that review are in yesterday's video. And so this is just a little sort of like puzzle, and the two numbers I can think of that add to 8 and multiply to 15 are 5 and 3, so I'm going to add x plus 5, x plus 3. That's certainly a product between one whole group and another whole group. And just to check my work, to make sure I'm not losing my mind, I'll re-multiply out x plus 5 times x plus 3. I'll distribute the x times x times 3, 5 times x, 5 times 3, x squared plus 3x plus 5x plus 15, and now we see it. The first term is the x squared. The middle is the combination of 3x and 5x, so we add the two numbers. 3 plus 5 is 8. And the last term is 3 times 5, which is 15. So that's our pattern hunting. So this is review here. And today we're going to spice it up. This is the new topic today. And there's something quite obviously different about this whole shape, namely this 2 out here. There's no coefficient for the x squared in any of the problems that we've studied so far. But there is here. And so how do I get a product where I multiply together in my products here to get a 2 out front as my coefficient in the beginning? And the thing is it's going to take both things that we've learned so far. The very first thing where we factored out a common factor, we undistributed a common x. And the second thing where we learned how to turn this trinomial quadratic, so this 3 different terms adding together with an x squared out front, into a multiplication problem of two groups. So I'm going to have to combine what I know from undistributing a common factor and factoring these quadratics to do something like this. So let me begin. Whenever I'm thinking about factoring an expression, the very first thing I do is I kind of check each term in the expression, and I think to myself, is there anything I can undistribute first? Is there a common factor that's in every single term? And this is something that, if you practice, you'll start to see. So in this case, there's definitely a 2 in all three terms hidden because these are all three even numbers, and even numbers always have 2 as a factor. There's an x in the first term and an x in the second term, but no x in the third term. Okay? So there's a 2 in every term, but there's not anything else in every single term. So what I'm going to attempt to do now is I'm going to attempt to undistribute a 2 from every single piece here. So you got to think to yourself, 2 times x squared, 2 times 13x, 2 times 40. So in my head, I'm rewriting each term so that I can pull out the common factor of 2, and what's left behind is an x squared, a 13x, and a 40. So that's 2 times the group x squared plus 13x plus 40. And so now that I've factored out a common factor from all three terms, I might ask myself, can I factor more? And if I can factor more, it's going to be an x game. And the x game is going to be a question. What adds and multiplies? So the 13 is going to be the number that we add to, and the 40 is going to be the number that we multiply to. So we need to think of two numbers that add to 13 and multiply to 40. And if I get stuck, I'm going to start with my multiplication problem, which is 40, and I'm going to think about number pairs that multiply to make 40, like 2 times 20. Those will add to 22, so that's not close enough to 13 to make me super happy. So I'll have to try something else. Another pair. 2, 3 doesn't seem to go into 40. I could try 4 and 10. 4 and 10 add to 14, but not to 13. Okay, so maybe I'll have to try 5. 5 goes into 40. 5 times 8 is 40, and 5 plus 8 is 13. Right, so you grab your factor pair, 5 and 8. So now we know that we can take this entire group in blue, and we can rewrite that entire blue group using our numbers 5 and 8. So the entire expression turns into 2 out front times x plus 5 times x plus 8. And the way I figured that out is first I factored a 2 out from the entire thing, and then I took the leftover quadratic here, x squared plus 13x plus 40 in parentheses, and I factored that into 2 factors, and now I line up 2 times the entire blue thing written in factored form. And just to make sure that I'm not going crazy, I'll remultiply 2 times the group x plus 5 times the group x plus 8 to see if I end up back where I started and I properly factored the entire expression, 2x squared plus 26x plus 80. So I'll go ahead and check that now. I can do this a lot of different ways. I could distribute the 2 first to get 2x plus 2 times 5, which is 10. And then I would have to multiply these two groups together. So now I'm going to have to multiply 2x times x, and then 2x times 8, 10 times x, 10 times 8. And now I'll clean it up, and I get 2x squared at the front, plus 16x, plus 10x, plus 80. And then in the middle, I have common factor, like terms. And 16x's and another 10x's is a total of 26x. And so this is what I started with, which means that I successfully factored 2x squared plus 26x plus 80 into this. So this will be my answer to the question, please completely factor the expression. I'll post one more example video for today. Thanks.